Problem number 1834, single-threaded CPU. You are given n tasks labeled from 0 to n minus 1, represented by a 2D integer array tasks, where task I equals in queue time I, processing time I, means that the ith task will be available to process at in queue time and will take processing time to finish processing. You have a single-threaded CPU that can process at most one task at a time and will act in the following way. If the CPU is idle and there are no available tasks to process, the CPU remains idle. If the CPU is idle and there are available tasks, the CPU will choose the one with the shortest process time. If multiple tasks have the same shortest processing time, it will choose the task with the smallest index. Once a task is started, the CPU will process the entire task without stopping. The CPU can finish a task, then start a new one instantly. Return the order in which the CPU will process the tasks. Let's see how is the range of the task length and the in-queue time, the range of the in-queue time and the process time. Okay, so the length of tasks will be at least 1, and in-queue time processing time will be larger than 0, so it is a positive integer. Okay, so tasks will be like this, and so it will choose, like, first of all, at time, let's say at time 1. Okay, so this is sorted, and yeah, maybe we can first sort the tasks, so that sort task by the in-queue time, so that we know which to process first. So at time 1, 0, the task number 0, task 0 will be processed, and time 2, task okay, so for when it will be finished, like task 0 will be finished at time 3, and at time 3, If the CPU is idle, there are available tasks. The CPU will choose the one with the shortest processing time. Okay, so I think we need a heap to maintain the shortest processing time tasks, and okay, so if the in queue time I'm thinking of there should be a min heap to keep track of the available shortest task. Oh, I think maybe like okay, we cannot, it is not. For the 7, it will choose 4 first. That is task 3 will be 4. Oh, it's 2. Okay, the first I think we can sort the task first, and then by in queue time, and then okay, there's we should maintain this min heap according to time. Like at time I, what are the tasks available? So I think but I came up with an idea that we maybe can like sum up, like the range of the time will be from the smallest, time range will be smallest EQ time to the total sum of processing time. Or if we sort the task by NQ time, we can add, like when to add task, when and how. I'll say like when looping, when at each iteration of time, when the next when the current if in Q time equals time I, then add task to heap. I think we will use while, since there may be more than one tasks. Okay, and then then we have we have the available tasks at time I. Should we add index? Because if they have the same process time, it will check its index. Okay. But I think like but we sort. We have sort this thing. If we don't sort it, index, So for comparing with index, you have to be available at the same time, and you have and the process time will be the same. Yeah, like maybe 7-4-7-4, then let me think. Yeah, maybe you have when it comes to index, task equals maybe 1-2, but the order is 2-4, and you have 3-4. Then you must first execute 2-4, since it's index is before 3-4. Yeah, but if it's the case, if it's like this, then after we sort, it will be okay. So the index that the one that has smaller index should be added first. Okay, the index is I have currently no idea how to deal with the index thing. For shortest processing time, or maybe let's first try without but Should we sort first? Can we sort? Yeah, the question is, can we sort with the time? Like for this, it is 3. Then this 2 is available. And it will pick this since it has smaller processing time. But let's see if this, like, it will execute this first, and then it's 3 on time 3. It will execute. It has to choose between these two. And like if we sort by time, this will be added first, and then this will be added second. But I'm not, like, if these two are added, I'm not sure which one will be at the top. Yeah, like if we have the same processing time, how can we maintain our order? And the other way may be create a dictionary, and the key will be the processing time, and we'll have the tasks in like list in order. So yeah, maybe that's a way. Or if we could, because when we when we add to the heap, we can only use like we know the current shortest processing time is maybe 4, but like we don't know which task to execute, so that's a problem. So it should be like min heap should be task processing time and task ID. Okay, so I think we'll first modify task list that first have n equals length tasks, and it will have answer is none multiplied by n, and size is n. Oh, and we will have tasks, new tasks that will be sorted by its processing time, in queue time. So that's a task with order that will be in queue and processing and ID, let's say index. So that will be for the first is in queue time. The other is processing and I in index in enumerate. Tasks. Okay, then we will sort and we will have a min heap to keep track of available tasks. And we will start from start time will be tasks order number 1 with its enqueuing time. And end time will be the sum of processing time. So that's for loop T in range start time and end time plus 1. So we will start adding available tasks. So when time t, the current available tasks are, well, we should first collect, and maybe we should check if there is if somebody is being processing. Okay. Maybe an array, CPU, and okay, so if CPU, I'm thinking like first, yeah, we should add available tasks first. So at each iteration of time I will include time. Okay, so while so the current for t okay, we need current tasks, and we need if yeah, like in queue time will be task order from if task order index I'm thinking if it's easier to just iterate this task order array so that this is all but then when we we should keep track of the CPU time and the task available, like if okay, let's try for its enq processing index in task. Oh, it lagged. In task order I think I will to remove this I want to redefine the states, like okay, so currently the changing stuff will be time and task, the CPU process, and tasks available and tasks not yet used. Let's say it's not processed and it's not in the available queue, not yet in the available queue. Yep. So each of this we should use like a variable to store them, and for time we will have a constant, not constant, but it will start from 0. It'll be an end and start from 0. And tasks for CPU, that's for skip. Tasks available will have heap, a main heap. And for tasks not yet in the available heap, I think if we have time, if we have current time, let's have task for CPU, and task not yet. Task for CPU, I think if we have current time, then it will be, first of all, we can just, the easiest way will be have a variable to keep track of the entire tasks. Like maybe 1 and 2, but I think maybe we can keep track of the finish time. Like it is in queue time plus its process time. And tasks not yet in the available heap, then we need maybe we will have a task pointer, to keep track of which task we are now on. Like the next available task. And it's ranging from 0 to n minus 1. So I think we can use like a while loop. And I will have current time. From 0, task available, we have it. Task for CPU, let's have CPU finish time. First we'll have 0. And next available task is 0. Okay, and let's have a while loop. So if next available task is equal to n, that means no task no task should be added to the available heap, and if available task is still have tests. If both are empty, then we will finish. And first of all, let's try to we have 2 things to do. One of it is to maintain the available tasks, and the other is to deal with the CPU stuff. Select the task for the CPU, update its finish time. So I think, let's just first deal with the available tasks. So Well, current time. Yeah, we'll start from next available task. So if task order with next available task, it's in kill time is smaller or equal to current time, then it should be added to available tasks. So available tasks, we'll use hip push available task, and we'll push with key with processing time. Processing time will be 1, and the next one will be its ID, task ID, so 2. Okay, so then we will now move on to the CPU thing. So if current time is so if CPU is idle, then that means current time is larger or equal to CPU finish time. Then we will pop out a task for the CPU to operate. So the finish time will be updated to will be current time plus process time. That means 0. Okay. And our answer should be task ID. Okay. I'm thinking, should we check if available task has tasks or not? Okay, let's leave it first. And else is when the CPU is busy, there is a task running, so then we can just move to the finish time. And since there's nothing that we can do when the CPU is busy. And but okay, there is something. Let's check if all our variables are updated. Like answer is updated in the correct situation, and for vote task we have push and pop. Okay. For current time, let's see. We only added when CPU is busy, and we will skip until at the I think it is reasonable, since when when we are at current time. Okay, so when current time is updated, then it will first check the smaller the task that can be available, so it will add and then so now current time is equal to CPU time, so the last CPU time, so it's available for CPU, and we will pop an available task to CPU, and then CPU finish time will be updated. And it will run through check again for the same not sure if we can move, like, for when whether CPU is full or idle, we can all update our current time. Okay, then first move on to the next available test. We should update, since we did not update. We should update after push, after adding tasks. So we will here add this seems reasonable. maybe here we should check. Oh, there is, sorry, I forgot, yeah, we should check here if next available task is smaller than n. And yeah, there is a time that it's idle but tasks are empty. Okay, else if not available task. Like idle but not available task is empty, so we will have to move to next available tasks. So current time can move to the next available task in queue time. So task order, next available task. And in queue time, and you will have to edit by one. Okay, so if this is next available time is still, no, maybe it's not. But then it will have, okay, so yeah, this is still smaller than n, so it's fine. I think we should not add here. Yeah, we should leave when adding to available task and add it here. Yeah. And so this will be if I think we can have else, then current time is equal to CPU finish time. If CPU is busy, I think we can have this to be faster. And then we will return answer. Okay.